So in this video, we'll discuss the t-test with unequal variances. So suppose we're doing a test to see if a new drug is more effective than a placebo, a very important example. So we have a drug we think can reduce cholesterol. So basically, we've given that drug to, looks like there's 18 people there. And then we have 14 people we gave a placebo, and we looked at the reductions in cholesterol. And the question is the mean reduction in cholesterol significantly higher for the drug than the placebo? And there always does turn out to be a placebo effect. You give somebody a sugar pill, and it always does have some effect. Don't ask me why. But if we look at the averages here, can we conclude they're significantly different? Well, we don't know yet, but let's take a look at them. So the average there would be 2.13. The average there, reduction is like 10. Okay, now that's a lot, that seems to be a lot bigger. Okay, but the question is, it's significantly bigger. So the null would be, we'll just make our font bigger. The null hypothesis is mean reduction for placebo and drug are equal. And the alternative is that they're not equal. So the first thing is, since we have small samples here, we should check for skewness and kurtosis, and then check are the variances equal. So if I do kurtosis, that's close to 0, that's great. Kurtosis for the drug, very close to 0. Skewness for the placebo reductions, not slew, that's a horse. Reduction, skewness is near 0, not less than -1. Skewness here, between plus and -1. So I can assume we have normal populations. We've got small sample size. We don't know the variance. So we're going to do a t-test. The question is, are the variances equal or not? So I can do that f-test. Okay, here's the first array. And then I put a comma. I point to the second array. And if there's a low p-value, I can assume unequal variances. And there'll be a really low p-value. That's 3 in 100,000. Okay, so there's only 3 chances in 100,000 that you'd see. Let's look at what those variances were, by the way. A discrepancy this large in the sample variances. For the placebo, we got a variance of 11. And for the drug, a variance of basically 1, the very small variance. The drug seemed to reduce almost everybody's cholesterol by the same amount. Okay, the placebo was all over the place. Sometimes it increased basically their cholesterol, which was to be expected. So now we can do the unequal variance test because this p-value for equal variances was very small. So I go data analysis, t-test, unequal variances this time. Okay, so variable 1 range, I can use the label. Variable 2 range, hypothesize mean difference 0, check the labels box because I selected the labels. I could put this in a new worksheet, but it's easier to put it here. And we just want that p-value. And wow, it's pretty small. The t-statistic is like -8. So the t-value basically here is going to be 8 in 10 million. So basically, that's very small. P-value less than or equal to any alpha. Reject the null hypothesis. Conclude a significant difference in cholesterol reduction between placebo and drug. In the next video, we'll show you how to do what's called a paired sample or match pairs test to test for difference between means in 2 populations.